right, let's do it. So, first things first. Verify. Make this look like that, okay? Or make that look like that. But it's going to be easier to work with the more complicated side. If you come here and you're like, this looks easier to me, making something easy look complicated is actually harder than making the complicated side simple, right? We want to avoid this because it looks gross, but we can't, okay? So here's our toolbox, right? All we can do is think of a tool here that would apply to what we're looking at. Write everything in terms of sine or cosine. Okay, I've got my cosines here. Could I write this as 1 over sine squared theta? Sure. Okay? Does that get me to the end? No. Because these are cosines, right? So I'm not so sure that's something I want to do. Could I do this? Yes, I could. Should I? Probably not. All right? Manipulate and substitute Pythagorean identities in for squared terms. Do I have a squared term? I do. But does substituting, what is cosecant squared? 1 plus cotangent squared? Does bringing this in place of that make it simpler? I don't know, not really. Because then it's cotangent, right? I brought in 2 terms instead of 1. So again, I don't want to poo-poo all these ideas. Could you do this? You could. But let's keep going through the list. What about factoring out common terms and the difference of squares? I have no factoring to do here. I do have, remember what we're looking for when we talk about factoring, I do have a minus sign. But what are you going to factor away from here? You can't factor part, like if you're like, oh, they both have a cosine. You can't factor part of a denominator out, right? That doesn't work. So we're not going to be able to do this. What about finding a common denominator and combining fractions? Okay, what about that idea? And you're like, yeah, I could, but that looks horrible. Well, sometimes it has to get worse before it gets better. Okay? So in this regard, could I find a common denominator? Yes. And this is why we did all of that pre-algebra stuff the very first day of this unit. Because of problems like this, right? It's horrible, you might not want to do it, but maybe you see this, okay? Maybe you see that if I multiply that denominator times the bottom and the top, what do I get if I multiply that down here, right? What are these? What's the magic word? What are these? Conjugates. So multiplying this times the bottom and the top, even though it looks horrible, makes a lot of sense. But we have to do it here too, right? We have to take this denominator and multiply it here and here, right? So we're doing cosine theta plus 1 on the top and the bottom here. I apologize for the spacing, but we get what we get with that. Okay? It's not unlike, you know, if I'm adding 3/4 and 1/5, the fastest way to do that is take the 5 here and here, take the 4 here and here. Now I have a common denominator. We've said it might not be the least common denominator, but it's a common denominator. And then I can actually combine them into one fraction, right? This is what we're doing. We're just doing it with horrible looking trig expressions. So what we end up with on the top over here is cosine theta minus 1. Now on the bottom, I am on record as saying this. When we multiply, we don't want to actually FOIL the whole, but I've said that before. This is the one exception. This is the one time where when we're doing this common denominator business, we do actually want to multiply these because what we said, these are conjugates. The product of conjugates is the difference of squares. So when I multiply cosine theta minus 1 and cosine theta plus 1, those are conjugates. Right? Again, not unlike this. These are conjugates. When I multiply them, when I multiply them, I get the difference of squares. So when I multiply these, I get the difference of squares. I've got this other fraction over here. Up top I'm going to have cosine theta plus 1, and on the bottom I have this. And the right side is what it is. I'm not touching that yet. So now I'm here. All I've done is found the common denominator and cleaned it up, right? We use the tool, and then we simplify. Okay? So we're here. Now I'm going to actually put them together. Still have that one denominator. Now, what happens when I take this, when I take these two terms, and I subtract these two terms? Keep that in mind, right? We did an example like this again earlier in the very first day. If you go back to the first day of this unit where we were working with fractions, and I said if you're subtracting more than one term in the numerator, you have to subtract both of these terms. So this numerator, I'm going to write the whole thing out if that's okay with you guys, is cosine theta minus 1 minus cosine theta minus 1. Everybody okay with that? And that's equal to this. Now when we keep simplifying, I haven't had to go back to the toolbox because finding the common denominator and combining the fractions has gotten me to this point, but it's still not done. Cosine theta, cosine minus cosine theta, these are opposites. They'll cancel, but these won't. That's a negative 2 over cosine squared theta minus 1, and that equals this. Now what? Now we've simplified that. We've combined the like terms and combined the, we found the common denominator and combined the fractions, finally. So we've simplified, we're not done, we can go back to the toolbox. Or, if you've done enough of these at this point, you don't need to go to the toolbox because you've got your radar going off. I call it the radar, I can't think of anything better to call it, right? Here's our toolbox. We have to start from scratch now after we made that one simplification. Could I write everything in terms of sine and cosine? Sure. Yes, I could. This is already cosine, but I could write this as 1 over sine squared. What about manipulating and substituting Pythagorean identities in for squared terms? Would that make a lot of sense in this problem? Well, we just said, if you wanted to, I'm not saying it has to happen, but I can do this. And if I do that, just because I've said before too, try stuff, write stuff down. You never know if it's going to help, when that spark's going to come. But when I look at this, and I look at this, and I start thinking, hey, wait a minute, that's one of those Pythagorean identities. I wonder if I can take the Pythagorean identity associated with cosine squared and 1 and get it to say this for me. So we go off into the margin, off to the side, and we say, okay, can I manipulate this? Can I get this thing to work for me? Can I get it to say cosine squared minus 1? Well, if I'm going to do that, it starts by subtracting the 1 over to here. The interim would look like this. And if I wanted to just say cosine squared minus 1, I need this to come over here. So now it does say cosine squared theta minus 1 equals negative sine squared theta. So there's the manipulation. Here comes the substitution. This is negative sine squared theta. There's a negative 2 up here. And this, by bringing that 1 over sine squared theta in, looks like that. It's crazy, right? And then the negatives cancel. So we have 2 sine squared theta equals 2 sine squared theta. Check. QED. You guys see that video? QED. Okay, so coming back to the beginning, we had two fractions. We wanted to combine them. To combine them, we need a common denominator. Then we actually combine this all the way to here. And then we had the cosecant squared. Okay? How do I get this to look like that? Well, I did two things, right? I manipulated this with the Pythagorean identities, and I substituted that in to get a sine squared instead of cosecant. Okay? Cosine and cosecant have nothing in common. Think about that for a second. When this said cosine squared and secant squared, they have nothing in common, right? But cosine squared does have something in common with sine squared. And if the goal is to have these two sides look the same, okay, then have them speak the same language, right? Awesome. You guys want to do another one? Okay, good.